you can do in your personal computer. So we can take out some part of, so we have server, okay, like that. We have operating system, we have database. But we can connect to this one from your PC. We can connect. We can connect. We can downsize of the server into your PC user. Okay, what? Graphical user interface. Some basic computation. So this strategy is called downsizing. Here we are saying downsizing. Downsize. Everybody wants to make your body slim, right? So downsize the server. How can we downsize? Some part of the operation we can take out from server to the PC user. So this is called the downsizing. Downsizing was a very, very hot issue when I joined the IT company. Actually, not IT company, IT department of the bank. So my first project was the downsizing of the banking system. Then at the time, this one is called what? Still server. We are using database. Then this is called client. So this is called client server environment, CS environment. How many tier? 1 tier, 2 tier. So this is called 2-tier architecture. Is it only for the database server? No. Well, web server is 2-tier. What else? Any kind of service. Server means provide service. Okay? And client is request. At the time, network and PC power, we can separate job. This is a client server environment, client architecture. Here we use client server architecture. Like your project. Sometimes a project is based on the web base. I have web server as well as client module. Okay? Benefit. We can. This is good for 10 users. What if we have 100? What if we have 200? Yes, we can upgrade only this part, then connect it. So it's reasonably scalable. Also, we don't have to worry about the client part, focus on database or server part, server implementation, front end, back end. Since that time, we have something front end program, server, the back end program, server side, client side. Right? Problem. There are many problems actually here. One of the key problem was still this is not scalable forever. Why? Suppose that this is based on the TCP/IP connection. What is a TCP/IP connection? They are using every day the socket program. Socket is the very basic, okay? The network program, the Unix program. So, how can you communicate? How can you get the data? How can you request the data between server and client? You need to have protocol. Promise. How can we comment? My mother tongue is not English. Some of you guys are not raised on the English. How can we communicate? Because we are using the common language in English, right? Just like that, in computer cannot definitely understand what I'm saying, what you are saying. They cannot communicate each other automatically. No. We make the promise. We are going to use this way. Data structure, network data structure. As I said, all of computer science is based on the data structure. They make the rule, policy for communication. That is called the network protocol. One of them is a TCP/IP. They are they use the TCP and IP layer among the 7 OSI layer in network for communication. Which means the server side, it has the IP and port number. They open then this client request using that information on IP layer. Okay? However, whenever you make the connection, that means it needs resource, computer resource. For example, memory. There should be processor. Server means it's a server process. HTTPD or database process. They need this amount of memory. When you have 100 users, this is limited by the server side resource. To address, we need to increase. It's a limited. So it's not a good idea. Why? For example, when I worked for the bank, we have the 3,000 users, 3,000 employees, which means 3,000 connections to the server. Do you think how many of them are actually working? Most of them, they try to pretend they are working. So they never disconnect the connection to the server. They try to show they are working something. So they keep the connection until they left. Even some of the employees, they never disconnect. Never log out, then go back to home, then come to the office again. Anyway, so how many of them are active users? Only 2 or 3 at the moment, out of 3,000. It's not effective. Okay? What if can we make the establish the connection only for active user? That's the idea of we have server, we have operating system, we have database, we have client. Instead of client request the server side resource directly, we have middleware. Okay? This middleware receives the connection, the request from the client. However, between middleware and server, there is dedicated connection, only 3. Then, the main role of middleware is what? Assign this connection based on the request. So management, transaction management. So this is called TP. Sometimes transaction protocol process, whatever. TP monitor is called. I cannot remember the acronym. So many. Okay. How many tier? 1, 2, 3. So this is called 3-tier architecture, which is very popular nowadays. In terms of database point of view, how many connections? Only 3. Then TP monitor manage. So client-side database. So long time ago, database actually charged based on connection, or sometimes, user. It's okay. However, in this architecture, how many users? In terms of database, 3 users, even though they are 3,000 clients. So they changed the policy based on server side resource. How many CPU? What is the size of memory? So this is called the 3-tier. Any other example, sample of the 3-tier architecture? Everywhere, actually. Okay? Even in your office, it's a department chair, secretary, student. You can ask the secretary, can you arrange the appointment with the department chair? And there is something available to assign. This 3-tier architecture. And what about this in computer? Web server. Web server is also 3-tier architecture. Have you ever heard about the AP server, application server? AP server include not only web service like the HTTPD, but also it has middleware, the transaction control, like the HTTP request, Oracle application server. Well, WebSphere is application server, and WebLogic is also application server. And nowadays, almost all the web server include AP server. That means there's a 3-tier architecture. So, what about 4-tier? Yes, if you add some more security level or something other, it's an additional tier. So this is a the database, the DBMS architecture. Okay. What about your project? If in your project, it can be either 2-tier architecture or 3-tier architecture. It's up to you. Many of the web-based approach, web interface is based on this one because it has database server, it has a web server, and the user. If you are using the standalone application front end, as for the front end program, if you are using the standalone program, it will be 2-tier. It doesn't matter. There are different types of the DBMS system, but in this class we are not going to discuss details about such a homogeneous and heterogeneous, but it can be discussed in the distributed and parallel database management system or the advanced topics of the database in other class. Okay, so I'm going to skip this part. And also for the database model, we have a bunch of others actually. So network model, which is based on the relationship between the entity, okay, as a network, and hierarchical model, and object-oriented model, object-relational model. Among them, in this class, we are going to use the relational model to model the data. Okay, is that the only solution? No, we have a bunch of others, but the only reason I selected this, the relational model, is which is most popular nowadays. Actually, that is the problem. Think about your application program. Think about the network model. Think about the other software engineering. Most of them include object in their architecture, right? What about the database? Database is still in the relational model, which is a very strong model. It's easy to learn, easy to understand, but it's a very strong. What is the model? Model is set of concept, rule, policy. It's a strong rule, strong policy, which means it's not flexible. So this data model is different from program application. This is different from even operating system. This is different from interface. That causes a lot of problems. That makes the user harder and harder to implement. Okay? And that causes the performance degradation. To address that problem, there are many other alternative ways. For example, in terms of the developing environment like the IDE, they try to hide database model inside the object, like as a component. Okay? Then user can just call the object when they want to access the database. Okay? But inside of that object is purely based on relational model. So in this class, we will talk about the relational model, then followed by how to make the program between the relational model and other program methods. Okay? Any questions so far?
So,
Yes.
treat the model if more than 3 users is needed.
This one?
More than 3 connection is needed.
What needed?
Like more than 3 connection is needed. Is that-
3 connection, no. It's just in this case.
Yeah.
So first, if you start up, first you need to start up database or server. Then you need to start the middleware. Then middleware will connect the dedicated assigned connection. In this case, 2. Then once client requests the service to middleware, see which connection is available. Then assign this one. Then other connection, then there is no available, it will be on the queue. Then once one of them is the available, then assign that one. Something like that. Okay? So what is the title of this course? It's a database design. So we are going to start this lecture with the designing the database. So before that, we need to clarify what is the design. What is our goal of this class? We'd like to build a database for some requirement, like the university database, company database, or transportation database, any database. That database will be used by application or user. So that's our goal. So that database will be implemented in the computer. Actually, that's the problem. Where is the information? Information are everywhere in our daily life. Suppose that we are going to build a company database. Let's say this is a company. So we'd like to manage all the information in the company, not all, some of the important information. We'd like to keep track of such important information in our database system. So can you just ask to the computer, why don't you manage this information? No, definitely not. Computer cannot understand what you are asking. Computer cannot understand even what you are saying. Instead, we need to make the structure. Okay, computer can understand such a structured data. Okay, how can you make the structure? At that time, we need to pick up model. Okay, so from information, our goal is to build a database. There are a long way to do. So it's kind of a step by step. Okay? It's not the song. It's a step by step. Getting close to. This is just the information everywhere. But this is well-structured data in a computer. We need to getting close to that structured data. First step is we need to pick up some important information. Those are worthwhile to be managed. In the system, we need to collect such information, then organize such data, such information before we make that information data. Okay, that is called conceptual modeling or logical modeling. To do that, there are a bunch of other ways. Many ways to do such a conceptual modeling or logical modeling. Among them, we will learn about ER modeling. E represents entity, R represents relationship. Okay? This is kind of a rule. Okay? We will use this one. The main reason of this is it's very easy, very convenient. And also it can be applied to the many different systems. But be careful. Do we need any computer skill to do such a logical modeling? No. Do we need any computer science programming knowledge? No, we don't need. The most important knowledge that you need to do conceptual modeling is data itself, information itself. If you do not understand this information, you cannot do that, even though you got the A+ in your programming class. If you cannot analyze the data, if you cannot read the report from your customer, you cannot do such a model. This logical modeling determine almost everything of your this. Actually, the other step is just straightforward. You can just follow the step by step, as mentioned in the textbook. However, this logical modeling nobody explained. Sometimes it's based on experience. Sometimes it's based on your personal knowledge. Okay, that is the reason many of the big projects, mega-sized projects, they hire some specialists who can do such a logical model, mostly from business. Right. But if you are able to both logical modeling and the other, that's much better. You can consider eventually we will use computing power, right, to manage such a model data. So if you understand this part, this will be more efficient and effective. So we will talk about such a logical modeling throughout the semester. Why don't you see the handout? You can download from test website. Chapter 7 and 8 handout. Throughout the semester, we are going to use the two main databases. It's a very simple database. One is a company database. Another one is a university database. So you can. The reason why we pick up the two basic databases are everybody knows what is a company. Right? If I use the biology database or the astronomy database, some of them know, but the others are not. So this is a very well known the information. You can do that. So you should be familiar with the company database and the university database. Okay. Before we start the ER modeling, the logical modeling, this diagram shows the overview of database design process. Why don't you see this part or this part? You have a problem, okay? Then you have the functional analysis, high-level transaction specification, and application program design, transaction implementation, application program. Have you ever seen this part? Yes. What are they? Where did you see this part, this process?
In the first chapter?
No. In your software engineering. And if you did any types of the computer science project or programming project, you probably did follow this process, whether or not you realize. For example, if your programming instructor in your programming class assigned, why don't you implement a Fibonacci sequence, some of the Fibonacci sequence. Problem, you need to analyze what kind of function you need. First, you need to understand what is a Fibonacci sequence. Then, how can you add what kind of function you need? Design. Okay, sometimes a flow chart, sometimes a UML diagram. Then, what is the input and output? Then, you need to design, application design. Then implement, test, and finally you can have the application program. In addition to the application analysis, we are doing database programming, database design. So we have, at the same time, it's not different, totally different thing. Simultaneously, we can have conceptual design only for data. Actually, you did same thing in your application analysis. However, at that time, data itself is very, very simple. Like in Fibonacci sequence, we have integer I. So 1. Then 1, 2, 3, 5, something like that. So add up, next. Data, we need just a simple. And also output, sum. You don't have to consider. But you already did in your application analysis. This is an integer. It's a data structure and data type. And output is the integer data type. So it's like that. However, we separate such a data part because we have very large data and also very complicated So that is called database analysis. Data analysis process. That consists of conceptual design, and logical design, and physical design. So we are going to start from conceptual design part, logical design. However, we cannot separate the application analysis, data analysis. When you are doing the real project, you should do interchangeable. Okay, every time. So, why don't you take a look at the handout, the second page. First, we are going to then use the company database. Requirement collection and analysis. We need to create a database schema design based on the following requirement of the company database. Who provides such information? Your customer. Okay? If not, you need to find by reading the report, by analyzing the business logic, or by analyzing the report, you need to find such a requirement. Then you can do the modeling. So this is very important, but in this case, it's clearly define such a problem. What about your project? The first step is, have you ever read the project description? What is the first step? Problem definition. You need to, because I believe you know what is a banking system already. So you can define the problem by yourself. Okay? So, for example, in this company database, company is organized into departments. Each department has a name, number, an employee who manages the department. We keep track of start date of the department manager. A department may have several locations. Something like that. I believe this is a general description of the department, but it can be different from your knowledge or your experience. Which one is the first? This or your idea? This. Never ever believe your idea when you design. Okay? That's the truth in your midterm and final exam. For example, I believe there are two department chairs. I learned such a way in my class. No. Even though that is true, I cannot give the credit because it's your idea. When you model the database, when you perform the database project, it's purely based on the requirement provided by your customer. If you are not sure, you need to ask the customer. Even your customer are not sure, they are not sure, you need to discuss and make the conference, then decide. Okay? So then, each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location. We store each employee's social security number, address, salary, sex, and birthday, and so on. Each employee may have a number of dependents, and so on. You cannot see such a well-organized the requirement or description rest of the time. Okay? Sometimes it's lousy, sometimes mixed, it's ambiguous. Okay? It's your job as a modeler, developer, designer to clearly define the problem, like this way. Okay? Okay? So, using this information, we are going to first step. Logical modeling. How? There are different ways of modeling. We will select ER model. Even though you do not know what is ER, don't worry, we will learn right away. There are several steps of ER modeling. The first step is find entity. The problem is, what is an entity? What is an entity? Probably you heard about the name of entity before. Table? Who said? You don't have to take this course. I don't know anything about table. Table is like this.
It's element. Element.
Table? Really? I don't know. How do you know? Forget about any knowledge or any experience about the database. Then we will learn the step by step. The entity is not a table yet. We don't know. It can be object later. It can be something else, component. Who knows? It depends on. If we are implemented just the application program without the database, it will be object, class. We don't know. So it's not table. What is an entity? Entity is just a thing. Okay? Existing. Okay? Everything can be the entity. For example, in this classroom, student, she's one entity. He is one entity. She is an entity. There are, what about the trash can? This is an entity. And the temperature, sometimes you can see visible, but it exists. So temperature can be an entity. Everything that exists can be entity. Okay? That's it. That's an entity. But we don't want to find all entities. We want to find the entities that are described in the requirement description. As we have defined in the last week, what is the data? Data is important, meaningful information. Okay? Among the information, we try to pick up the meaningful, important information. That is an entity. For example, in this, before this example, in this classroom, I'd like to find the entities. So Abir is an entity. And Sami is also an entity. And Faisal is an entity. He or she, each of the student an entity. Okay? What about the trash can?
It's an entity.
It's an entity, and temperature is 72 degrees Fahrenheit. It's an entity. You can see these three has the same meaning, right? As a what? It's a student. They are not student. By grouping this entity, we can find student, entity, actually type. This is called student entity type. Each of student is entity. So from information, university information, what company information, I try to find eventually entity type. How can you find entity type? Collect all meaningful entity, then classify by the meaning. These guys are students, so I can define entity type. Okay? How can you describe this entity type, this student? We need a name, first name, last name, age, what else? The address, major, and so on. So there are a bunch of information that can describe this entity type. This is called attribute. So each entity type has the attribute. Among them, bunch of information for Abir, Sumi, and Faisal. We need to find. For example, do you think the Abir and Sami and Faisal, they have exactly same information?
No.
Sometimes not. Some of them are interested in the hobby, the others are not. But you can find common information. That common information will be attribute of entity type. Okay, so the first step is to find, actually not entity, it's entity type. Let's go back to the company database. Let's start from the company database. Can you find any entity type from company database? Department, yes. Department is, this is already well organized. Probably your customer provide all department information. There is HR department. There is a payroll department. There is the ABC department, the sales department, and administrative. All of them are entities. You can find common information. It's a department information. Department entity type. So first you can find department as an entity what? Type. Actually, I do not provide the details information about entities. Okay? That makes more confused. But in real life system, you probably see list of the department from the report. Then you can select the department as an entity type. Any other entity type from this example? Employee, yes. Employee. There are a bunch of employees as an entity, but you can group as entity type. Employee entity type. What else? Project. You already realize it's already capital letter. Because this is the first step, I know. Not easy for those who never did the database design. So project. And what else? Dependent. Are they all entity type? What about the company? Company,
It's relation.
company itself. Can it be the entity type or not?
No.
How many companies do you have? One company. So if you build a company database in New York area, at that time company can be entity. However, system is for single company database. You don't have to manage the company name. Okay? However, if you have been asked by the customer, you have a history of the company the information, then at the time you can create. But I cannot find any requirement for that. So company will be ruled out. What about the location? Who said the location?
They have several locations.
Yes. Where is it? Last,
The third one. And then the third one.
we also,
A department may have
department, yes. Oh, a department may have several locations. So it's a kind of dilemma. Whether location, what about the name? So for employee's name. Name can be first name, last name, middle name, initial, right? What name? Can it be the entity? No, nobody said. What about the location? Location itself describe the department information. Okay? So it's your job as a designer, whether this goes to the entity or this goes to the attribute. In this case, if you have more information about the location,
It's gonna be.
Yeah, I should have
no, so we can manage We can say the location as the attribute of department, like the department name.
They don't have enough information to decide.
If you don't have,
enough information to decide.
yeah, you do not have enough information. So that's the reason we try to decide, regard such a location as the attribute, not the entity.
But the
Yes.
location has address, right?
Who said?
Location has address.
As I said, believe only the description, not your knowledge. I don't know whether location has the address or not. Okay? That's the truth. Yes,
No, but on the next,
I understand.
on the next requirement, you have mentioned that the project is located in a single location. So
That's the location of the project,
Yeah.
not, so we cannot say that it's the same location,
Right.
same
But
information.
Isn't it better to reduce the redundancy later on the database?
We are not sure yet whether that are redundant. Even though we are saying the name of department, name of employee, they are different. It's the same thing. So that is the reason we don't want to be risky by combining such information. Later we will address, okay? Whether if that is a redundant information, we can combine. So we can find, I know there might be many other opinions, that's the truth. Frankly speaking, in database design, there's no general answer. Like the programming, is there any the general code? Yes, the typical code can be, but her code and his code are identical? No. Sometimes different name, different the logic, but as long as it's correct, it's okay. Database is the same thing. Okay? There's no command, so that's the reason I actually provide very strong requirement and clear requirement for your practice. In real life project, it's much more complicated and also non-obvious. But since we are learning how to do the ER modeling, we'll consider very general step. Okay, so this is the entity type. But it's a little bit complicated. What is the entity? What is the entity type? That's the truth. So from now on, I'm going to use entity for entity type, which means if I'm saying the entity, that means it's an entity type. What about the real entity, each student? That's also entity, but not many times I will mention the entity of specific data. Okay? So from now on, I'm using the entity instead of the entity type. So if Professor Lee is saying entity, that means entity type. Except your exam. In your final, at the midterm or final exam, I'm going to ask the definition of entity type. And what is an entity? What is an entity type? You should be able to answer. Except that, so entity means entity type. Also, one more thing. Entity plus entity type is called entity set. So student, employee, entity set means the entity type, the employee, plus the real employee, the Patel, Lee, and so on. This is called entity set. However, from now on, I'm going to call all of this as just an entity. So how many entities we have? Four entities we find. What is our goal of database design? Eventually, we'd like to build a database on the computer. Okay? To do that, list of entities. Sometimes these are hard to understand. Usually, diagram or symbol is better than the description, right? So everybody understand what that means, even though you do not know. It's a stop instead of stop. Okay? So we are going to consider such a diagram or the symbol. To represent the entity, we use rectangle. So whenever you see the rectangle, that means it's an entity. Actually, entity type. So entity type is this. Next step is for each entity type. For each entity, we are going to identify the attribute. What is attribute? Attribute is the attribute describe each entity. So for example, department. Each department has a name and number, department number, and employee, manager. That means manager. And we keep track of start date of the manager. Also, department may have several locations. What about the project? Project has a unique name and unique number and located at a single location. And so on. That's the attribute. Yes.
Manager is an attribute. Manager is an attribute.
Yes. Department has a manager.
I know.
Yes.
This is
That I understand what you are confusing. So that's the reason I ask you forget about any knowledge, any experience on the database before you have. Okay? Momentarily, forget about it. Okay? Then you will understand later why Professor Lee first put the manager as the attribute.
Because it's related to the department.
I don't know what is the related. Yeah. Okay? We are not going to, our goal is not design only this. Our goal is to understand process of ER modeling. Okay? This is a simple. Even without understanding, without knowing the ER modeling, you can design the company database, a simple database. But the more important thing is whether you can understand the process of database design. So these are the attributes of department entity. These are the attributes of project. We will use over to represent each attribute, then connect it. This is the same. Then we can easily understand. Instead of describe the statement, this is much easier to understand, right? So the next step is find attribute of each entity type. Then use over, then connect. Why don't you find this one and this one too? Using the provide information. You can use a handout. Okay, what about the employee? Social security number
Address.
and address and salary and sex and EOB, first day. Okay? Then dependent, name and sex and DOB and relationship to employee. Relationship. Later we will consider together. Then you can circle, it's over, connect. That's the second step. Very easy. Identify the entity. If you do not have the clear entity set and entity type, you need to identify all entities, then grouping. Which one is common, which one are not. So common entities will be entity type, then rectangle. Rectangle, rectangle, rectangle. After that, you can find the